Right now, at this very moment, as you watch this video, somewhere in this vast universe, another person is sitting. A person who looks exactly like you. Same face, same fingerprints, the same entire life. And this isn't science fiction. This is a direct conclusion of modern physics. Humans have always asked one burning question. Is our world alone? Is this universe we see around us all there is? Or does something exist beyond it? A physicist named Max Tegmark dared to answer that question, and his answer was staggering. He said parallel universes don't just exist in ones or twos. They come in 4 distinct levels. A ladder where every step upward becomes more mind-bending, more vast, and more terrifying than the last. At level 1, a perfect copy of you exists somewhere out there. At level 2, entire universes exist where the laws of physics themselves are completely different. At level 3, every single choice you make splits reality into 2 separate branches. And at level 4, the final, most shocking level, he says something that will pull the ground right out from under your feet. He claims that you, me, this entire world, are nothing more than a mathematical equation. Today, we climb this ladder together. Step by step, we'll unpack all 4 levels. We'll explore the story of the scientist who conceived this extraordinary idea. And finally, we'll face the biggest question of all. Just how many universes can possibly exist? To understand this fully, we need to start at the beginning. Because the question of other worlds is not new. It has lived somewhere in the human mind since the very start. For thousands of years, it remained pure imagination, a story, a dream, with no science to support it. But slowly, as our tools grew sharper, everything began to change. Thousands of years ago, humans believed Earth was the center of the entire universe. The sun, the moon, the stars. Everything revolved around us. It was a deeply comforting idea. We were special. We were at the center. Thinkers like Aristotle championed this view. Then came the earthquake. The discovery that Earth was not the center. That we were simply another planet orbiting the sun. It knocked humanity off its pedestal. And yet, even then, people assumed our galaxy was the entire universe. That debate was finally settled by one man whose name was permanently written into history. He found evidence that shattered our entire picture of the cosmos. Beyond our galaxy lay 2 trillion more galaxies. Yes, 2 trillion. Each containing billions of stars. What we once called the whole universe turned out to be a single drop in an incomprehensibly vast ocean. Notice the pattern. First, Earth was the center, then the sun, then our galaxy. Each time, we discovered we were smaller and less central than we imagined. And this pattern points towards something even more radical. Now let's meet the man who divided the entire multiverse into 4 levels. His name is Max Tegmark, and his story begins in childhood, in a small town in Sweden. Max grew up between 2 completely different worlds living under one roof. On one side was his father Harald, a mathematician, a deeply logical and disciplined man who believed that everything in existence, from a single snowflake to an entire galaxy, could be understood if you found the right equation. For him, mathematics was the answer to everything. On the other side was his mother Karen, an artist, a writer, who filled their home with color and imagination. What if mathematics isn't just a tool we use to understand reality, but reality itself? Imagine a child growing up at a dinner table where conversations swung between abstract mathematics and the deepest questions about existence. His father saw precise patterns in cold, hard data. His mother found those same patterns in a single brushstroke, 2 worlds colliding. And from that collision, a rare gift emerged. Precision from one side, wonder from the other. While other kids were lost in video games, this boy stayed up late into the night, sketching geometric patterns by lamplight. Numbers fascinated him, not because they gave answers, but because they seemed to whisper something hidden. As if behind every number, a deeper design was waiting to be discovered. And that's when a question formed in his young mind. A question so wild, so audacious, he couldn't say it out loud to anyone. The question was this: we use math to measure the world, right? But what if math isn't just a tool? What if math is the world? At first, that sounds strange. We assume reality is built from physical things, atoms, energy, forces. And math is just the language we use to describe them. Like a map isn't the city, it only represents it. But this boy had a completely opposite thought. What if the map is the city? What if everything we call real is simply mathematics wearing different disguises? That question became his compass, silently guiding every choice he would ever make. In school, while other students solved equations just to get the answer, he was lost in their hidden beauty. Teachers called him a dreamer, brilliantly talented, but always somewhere else entirely. He wasn't satisfied knowing how math works. He needed to know why it works so perfectly. And here's the crucial insight. Because everything that follows depends on it. He noticed something deeply strange about mathematics. No matter what new physics we discover, no matter how far we peer into the cosmos, math is always there waiting for us. In the movement of electrons, in the spinning of galaxies, in the behavior of light itself. It's as if the universe speaks only one language, and that language is mathematics. That realization shook him to his core. Eventually, his studies took him to Stockholm, and by then his suspicion had hardened into something close to conviction. Reality itself might be fundamentally mathematical. His papers began attracting serious attention, not for being flashy, but because they fused rigorous logic with the deepest questions about existence. And that burning curiosity ultimately carried him to one of the most legendary institutions on Earth, MIT, a place where the language of the universe is spoken fluently every single day. Max Tegmark was on the verge of building his theory, that our universe isn't alone, but one of infinitely many. But before that theory could stand, one thing had to be proven first. It had to be shown that our own Milky Way isn't everything, that something vast exists beyond it. And that takes us back to 1929 on a mountaintop in California. Remember the Great Debate? Scientists were fiercely divided. One side insisted the Milky Way was the entire universe. The other side argued those faint, blurry smudges in the sky were actually entirely separate galaxies. The argument had raged for years, and nobody had solid proof. Because proving it required measuring something extraordinarily difficult to measure: distance. How far away were those smudges? If they were close, they belonged to our galaxy. If they were unimaginably far, everything would change. Enter Edwin Hubble, a man who began his career as a lawyer before becoming one of history's greatest astronomers. Hubble was working with the most powerful telescope of his era, the Hooker telescope at Mount Wilson Observatory, and he had made himself a promise. He was going to end this debate forever, beating like a living heart. And the most remarkable thing about these stars is that the speed of their pulse is directly linked to their true brightness. Which means if you can measure how fast a star is beating, you can calculate exactly how luminous it really is. There was a galaxy called Andromeda, and deep inside it, these Cepheid stars were discovered. Their pulses were measured, their brightness calculated, and their distance determined. And the answer that came back changed history forever. That fuzzy smudge. Andromeda was not part of our Milky Way at all. According to those calculations, Andromeda was so impossibly far away that its light took millions of years just to reach us. Today we know it sits roughly 2.5 million light years away. That means the light from Andromeda entering your eyes right now left its source long before human civilization even existed. Our picture of the universe changed forever. The Milky Way was no longer everything. It was just one single galaxy in a vast, endless cosmic ocean. And beyond it, countless more galaxies stretching into infinity. Once again, the edge of the universe had moved further away. And suddenly we realized, we are nothing but a tiny dot in an infinite cosmos. And right here rises the biggest question at the heart of everything we're exploring today. When we discovered that galaxies weren't unique, that there were countless of them, one burning question became inevitable for any scientific mind. If galaxies can be infinite in number, could universes be infinite too? If the Milky Way wasn't alone, what if our universe isn't alone either? This is exactly where the extraordinary framework begins, a layered structure of multiple universes. The very first level claims that somewhere out there, a perfect copy of you already exists. And that first level is what we're diving into right now. Welcome to Level 1, the least mind-bending of all the levels, yet still powerful enough to shake you to your core. To understand Level 1, we only need to accept one thing, something scientists already widely accept, that space is truly infinite. It stretches endlessly in every direction, with no walls, no edges, no boundaries whatsoever. Now think about this carefully, because this is where everything begins. Our universe is built from atoms and particles. The number of ways these particles can arrange themselves is enormous, but it is not infinite. It's like a deck of cards. No matter how many times you shuffle, eventually the same arrangement must appear again, because no new arrangements are being created, only the same ones repeating. When possibilities are infinite but arrangements are limited, one thing becomes absolutely certain. Somewhere out there, the exact same arrangement that exists here must repeat, which means if you traveled far enough through space, unimaginably far, you would find a place where someone is living your life. sharing your memories, making your choices. Right now, in this very moment, that person might be watching this exact video, a perfect copy, a cosmic doppelganger existing somewhere in the infinite expanse. No matter how astronomically large a number is, it means nothing against true infinity. In infinity, everything that is possible doesn't just might happen, it must happen somewhere. And here's one more crucial thing to understand. We can't actually see the entire infinite universe. We can only see as far as light has had time to travel to reach us. This visible region is called the observable universe, essentially our own cosmic bubble. That other universe at level 1 isn't some magical alternate dimension. The laws of physics there are identical to ours. Same gravity, same light, same everything. The only difference is that the atoms there are arranged in a different combination. And among those countless combinations, at least one is an exact, perfect mirror of our own. This is what makes level 1 so devastatingly solid. It doesn't rely on exotic new physics or wild speculation. It rests on just two simple facts. 1, that space is infinite, and 2, that atoms can only combine in a limited number of ways. If both of those are true, and the evidence strongly suggests they are, so scientists believe this is true, and that means the existence of your exact copy somewhere out there becomes almost certain. But here's the thing. That was only the first level. Up to that point, the rules were still familiar, still like ours. But at the next level, things get far stranger. Because at level 2, entire universes exist, where the laws of physics themselves are completely different from our own. Now we climb to the second rung, level 2. And this is where reality starts to truly break apart. At level 1, the rules were the same as ours. But at level 2, the rules themselves change. To understand this, we have to travel back to the very first moment after the Big Bang. There's a scientific theory called inflation. It says that in an unimaginably tiny fraction of a second after the Big Bang, our universe expanded at a mind-bending speed, from a single point to an enormous cosmos. But here's the twist. Some scientists believe that inflation never fully stopped. It pauses in certain places, and wherever it pauses, a universe is born, like bubbles forming in boiling water. Our entire universe is just one of those bubbles. And in that vast, churning ocean, countless other bubbles are forming right now, each one a completely separate world. But here's the part that's both fascinating and deeply unsettling. Most of those universes would be completely dead. Imagine a universe where gravity was just slightly too strong. It would collapse in on itself the moment it was born. Or one where gravity was just slightly too weak. No galaxies, no stars, just scattered gas drifting forever in darkness. Life wouldn't even be a remote possibility. Most bubbles are dead bubbles. Empty, lifeless, dark. And among all of them, our universe is a rare and extraordinary bubble. One where the rules came out just right, and eventually, you and everything around you came to exist. This brings us to one of the deepest questions in science. What physicists call fine-tuning. How are the laws of our universe so perfectly calibrated? Gravity not too strong, not too weak. Every constant dialed in exactly as needed for life to emerge. How can this possibly be a coincidence? Level 2 offers a stunning answer. Maybe it isn't a coincidence at all. Maybe there are infinite bubbles, each with different rules. Most are barren, but wherever the rules happen to allow life, life appeared. And we, of course, are in one of those rare bubbles. Because if we weren't, we wouldn't be here asking the question. So now we have two levels. Level 1, where your copy exists somewhere far away. Level 2, where the laws of physics themselves differ from universe to universe. But both of those levels had one thing in common. They existed somewhere out there, beyond us, in distant space. Level 3 shatters that idea completely. It says other universes aren't far away at all. They're right here, in this very room, right beside you. And they're being created every single moment. Welcome to Level 3, arguably the most mind-bending and most famous level of all. To understand it, we have to descend into the smallest, strangest world that exists. The world of atoms and particles, the quantum world. In our everyday reality, everything is clear-cut. A ball is either here or there. But in the quantum world, the rules are completely different. A particle can exist in multiple places at the same time, until the moment you observe it. Before that, it exists as a strange, ghostly cloud of possibilities, hovering across many states at once. But the instant you measure it, the instant you look, it snaps into one single location. All other possibilities vanish. This is the deepest mystery at the heart of quantum physics. The real question is, when you observe something, where do all the other possibilities actually go? And there's one legendary example that captures this mystery perfectly. You've probably heard of it: Schrödinger's cat. Imagine a sealed box containing a cat, along with a quantum trigger that may or may not release a deadly poison, governed entirely by the laws of quantum mechanics. Until the moment you open that box and look inside, that cat is simultaneously alive and dead, both at once. It sounds absurd, doesn't it? But that is literally how the quantum world operates. For years, scientists insisted that the other possibilities simply vanish. But then, in 1957, a young physicist named Hugh Everett gave a completely different answer. An answer so radical, so mind-bending, that people laughed in his face. Everett said those other possibilities don't disappear at all. Every single one of them becomes real, just in a separate universe. Let's break that down with an example. Imagine you flip a coin. By normal logic, you get either heads or tails. One outcome, not both. But Everett said, no. The instant that coin is flipped, reality itself splits in two. In one universe, it lands heads. And at that exact same moment, in a brand new universe, it lands tails. Both outcomes are real, just in different universes. Now feel the true weight of that idea. Every single moment of your life, thousands of quantum events are firing off. And with each one, reality is branching again and again. When you chose tea this morning, a universe was born where you chose coffee. When you pressed play on this video, a universe was born where you didn't. Every single moment, infinite universes are being created. There's a universe where you live in a completely different city. One where you chose a totally different career. One where your biggest mistake never happened at all. These universes are all real, and they are all splitting away from you, right now, every second. This extraordinary idea is called the many worlds interpretation. But the most heartbreaking part of this entire story is the life of Everett himself. When he presented this idea to the world, he was met with such ridicule and humiliation that he abandoned physics forever. A man who fundamentally changed how we understand reality was dismissed as a madman by the very scientists of his time. He walked away from the world of physics and lived a troubled life, dying far too young. And the greatest tragedy of all? Today, decades later, many of the world's leading scientists take Everett's idea with profound seriousness. The theory that was once laughed at is now one of the most respected frameworks in all of quantum physics. But that recognition never came while Everett was still alive. So now we have 3 levels. And this is where physicist Max Tegmark says something that will genuinely shock you. He claims that level 1 and level 3, which seem completely different, are actually the same thing. How can that possibly be true? We'll explore that stunning revelation next. So having climbed 3 levels, Max Tegmark now reframes the entire picture with one powerful insight. He says level 1 and level 3 are simply 2 sides of the same coin. At first, that seems impossible. In level 1, your copy exists somewhere impossibly far away in infinite space. In level 3, other universes are branching off right beside you every single moment. So how are they the same? Tegmark's answer is elegant. He says the only difference between them is location, where exactly your other copy lives. In level 1, all those possibilities exist within the same infinite space, just unimaginably far apart. Somewhere out there is the version of you who had coffee. Somewhere vastly further is the version who had tea. Same space, different locations. In level 3, those exact same possibilities exist across separate quantum branches. One branch with coffee, another with tea. Same possibilities, different universes. The only difference is that in level 1, these copies exist far away in space, while in level 3, they exist in separate quantum branches. But the possibilities themselves are identical. Whether you look across the vast expanse of space or through the countless branches of quantum reality, every possible version exists. The location changes, but the story remains the same. And now comes the real question, the one that takes us to the highest and most mind-bending rung of this entire ladder. Look closely at all 3 levels. There is one thing they all share, one thing that remains constant across every single one of them, and that is math, the equations of physics. In level 1, your copy's universe runs on the same math as ours. In level 2, even if the settings of the laws change, the underlying mathematical structure stays the same. And in level 3, all those quantum branches are running on the very same equations of quantum mechanics. Think about what this means. No matter how vast we made the universe, no matter how many levels we added, one thing remained at the foundation of every single one: math. Everything, in the end, rests on mathematics. And this is exactly where that childhood question comes rushing back. What if math isn't just a tool? What if math itself is reality? If beneath every level, beneath every universe, we always find math at the bottom, then one question becomes impossible to ignore. We have always treated math as a language that describes the universe. But what if we have it completely backwards? What if math doesn't describe the universe? What if math is the universe? Tegmark pushes this even further. He says that to truly understand reality, we must accept one thing: that there exists a world completely independent of human beings. A world that would exist exactly as it is whether we humans are here or not, whether we observe it or not. If that world is truly independent of us, then our human languages, our words, our descriptions mean nothing to it. What remains is the only thing that doesn't depend on any human, and that is math. 1 + 2 = 3, whether any human writes it down or not. That is why, for Tegmark, the deepest layer of reality can only be math itself. Until now, we said the universe is one thing, and math is the tool we use to understand it. But Tegmark said, why not consider that the universe and math are not two separate things at all? That math is reality. And if that is true, a staggering conclusion follows. If every mathematical equation corresponds to a real universe, then why only our equations? There are countless possible mathematical structures in existence. Do they all have their own universes? And this thought leads us to the final and most explosive rung of the ladder, level 4. The level where math itself becomes reality. We have now reached the highest and most mind-bending point of this entire journey, level 4. And be warned, what comes next will sound like it goes beyond even science fiction. But this is a serious idea from a serious scientist. Tegmark's reasoning was this: if math is at the bottom of everything, why not take one final step? Why not accept that there is no difference between reality and math at all? That every mathematical structure, which is internally consistent, free of contradictions, is a real, physical, existing universe. Let's think about this carefully. The equations that run our universe are a specific mathematical structure. Tegmark says this structure is real, and that is precisely why our universe is real. But mathematics contains countless other possible structures, countless different equations with different laws, and level 4 declares that every single one of those structures is a real, living, breathing universe. To understand this, consider the perfect example of chess. Think about it. Where do the rules of chess actually live? They don't exist inside any single board. They don't live inside any player's mind. The rules of chess simply exist. Even if there wasn't a single chessboard anywhere in the world, those rules would still be true. They aren't a human invention. They are a truth that always was. Tegmark argues that every mathematical structure is exactly like the rules of chess. It simply exists. And what exists is a real universe. Now think about what this truly means. Imagine universes where there aren't 3 dimensions, but 10. Where time doesn't move in a straight line, but curves back in a circle. Where even the laws of logic we consider absolute simply don't apply. Every single thing that is mathematically possible. In level 4, that becomes a real universe. And here's the most staggering part. Tegmark says you yourself are part of one of those mathematical structures. Your body, your thoughts, your memories, your very feeling of being alive. All of it is, at its core, mathematics. You are a mathematical structure that is experiencing itself. Now, to be completely honest, this is where things get genuinely complicated. Cosmic inflation, quantum mechanics. As strange as they are, they stand on real, testable science. But level 4 is something entirely different. It is a philosophical idea, a way of thinking. Proving it through any experiment may be completely impossible. You can never walk into a lab and test whether reality is mathematics or not. So let's be clear. Level 4 is not a proven fact. It is one person's extraordinarily bold and breathtakingly beautiful idea. But here's the one thing that makes it impossible to simply dismiss. Tegmark was not alone in thinking this way. Others were arriving at the same destination by completely different roads. We'll explore that next. So Max Tegmark said reality is fundamentally mathematics. But he wasn't alone. Some of the world's greatest scientists and thinkers, traveling completely different paths, were arriving at almost exactly the same conclusion. And that is what makes this so fascinating. When different roads lead to the same destination, perhaps that destination holds something true. The first road belonged to a philosopher named Nick Bostrom. In 2003, he raised a question that has since become famous across the entire world: the simulation hypothesis. Bostrom laid out a remarkably simple logic. he said. "Look at how advanced our games and computers already are. Now imagine thousands of years into the future. How unimaginably powerful an advanced civilization would be. They could simulate an entire world inside a computer. A world whose inhabitants would never even realize they weren't real, that they were living inside a simulation." Bostrom then said, "If such advanced civilizations could run millions of simulations of their own history and ancestors, then consider this. In all of reality, there would be only one original world, but simulated worlds could number in the millions. So statistically, which world are you more likely to be living in?" Notice what this idea is pointing toward. If we are inside a simulation, then our entire reality is essentially a code, a program running on mathematics. And once again, at the very foundation, we find the same thing: math and information. Now let's look at the second road, something called the holographic principle. To understand it, think of a hologram on a card or a banknote. It's a flat, two-dimensional sticker. But when you tilt it and look at it from different angles, it appears as a three-dimensional image with real depth. A flat surface hiding information that projects an entire three-dimensional picture. Now apply that to reality itself. What if our three-dimensional universe is actually a projection? Encoded information written on a distant two-dimensional surface? We may be living like a hologram. What if everything you see, touch, and experience is actually being generated from data written on a flat surface? As wild as that sounds, it points to something profoundly deep, that the solid, physical world around us may not be the fundamental reality at all. What's truly real might be the information underlying it all. And this isn't just philosophical speculation. The holographic principle is grounded in real mathematics. Back in 1997, physicist Juan Maldacena mathematically demonstrated that a universe containing gravity can be completely described by information living on its boundary, a lower dimensional surface with no gravity at all. Science itself is telling us that reality is a projection of information. Three completely different paths: philosophy, computer science, and black hole physics. All converged on the exact same destination. Our universe may not be built from solid matter at all, but from mathematics and information. Now, when so many independent roads point toward the same answer, one final and enormous question remains. If reality truly is mathematics, and every mathematical structure is its own universe, then just how many universes are there? The answer might be the most staggering of all. So many that they simply cannot be counted. We're used to hearing big numbers: billions, trillions, countless. But this goes far beyond that. Max Tegmark's answer isn't that there are a huge number of universes. His answer is that there are exactly as many universes as there are possible mathematical structures. And mathematics has no limit. You can always construct new equations, new geometries, forever. That means the count of universes never stops at any number. It encompasses everything that can possibly be defined within mathematics. Every conceivable geometry, every possible set of laws, every imaginable world. And here's what makes this idea even more profound. In level 1, 2, and 3 multiverses, no matter how enormous the count of universes, they all run on the same underlying mathematics. But in level 4, every possible mathematical structure is itself a universe. This multiverse isn't just vast. It contains everything that can be consistently conceived, everything that can be thought without contradiction. Think of it like an unimaginably vast library. A library containing every book that could ever possibly be written, every combination of words, every conceivable story. Most of those books would be pure nonsense, meaningless strings of random letters. But buried within them would be books containing coherent worlds, real rules, genuine characters. Tegmark's multiverse is exactly that kind of library, except instead of books on shelves, it holds mathematical structures. Most are lifeless and incoherent, but somewhere among them is our universe, a structure so remarkably ordered that it gave rise to stars, planets, and conscious beings asking these very questions. Yet here, at the very end of this journey, it's only fair to acknowledge what some scientists rightly point out. Calling this pure science may be a stretch, and that criticism is completely valid. This entire idea could ultimately turn out to be wrong. Maybe this remains just a beautiful philosophy, but somewhere in this entire story, there is one thought that refuses to let go. And that is this. Whenever we humans look out into the universe, searching for meaning, we always find one language waiting for us. And that language is mathematics. And perhaps that is exactly why Tegmark's wild and audacious idea cannot simply be dismissed. Because standing at the very top of this long, winding staircase and looking back at everything we've climbed, one thing becomes crystal clear. That ancient question: is our world truly alone in existence? The answer to that might be a resounding, overwhelming no. And if Tegmark is right, then you are not just a human being. You are a single sentence written inside one book of an infinite, eternal library. A sentence so rare, so precise, so impossibly unique, that the entire universe had to exist just to write it. What a journey this has been.